Hi Algebra 1 students, this is Miss Penn. This is a video I've created for you guys to review graphing equations and inequalities. So first off, I want to go over a couple of examples of ways we can graph lines. So if we look at example 1, we have y equals negative 1/2 x plus 3. This is in slope-intercept form, y equals mx plus b, where m represents our slope, which is rise over run, and b represents our y-intercept. So if we take a look at this equation, we see that negative 1/2 is the slope, so that means we're going to go down 1 and over 2 to the right. We see that positive 3 is our b value, which is our y-intercept. So what that means is when I come over to the graph, I'm going to start by counting up from the origin to a y value of 3. Remember, this is my y-axis, this is my x-axis. Now to get another point on my line, I'm going to follow the slope, so I'm going to go down 1 unit and over 2 to get another point. And I can repeat that process. And I can even go to the left 2 and up 1. And once I have a couple points, then I can go ahead and draw a line connecting them. We get something like that. So example 2 gives us a different format. We don't have y equals mx plus b anymore. One thing you could do would be to get it into y equals mx plus b form. So if you feel really confident in isolating that y value to turn it into y equals mx plus b, that is one option. But you do have another option, which is finding the x and y intercepts. And the idea there is you'll plug in, first you can plug in x equals 0 to find the y-intercept. So that would be 3 times 0 plus 4y is equal to 12. 3 times 0 is 0, so we get 4y is equal to 12. Thus y is equal to 3. So now I have my y-intercept at 0, 3. I can do a similar process to find the x-intercept. So here what I can do is set y equals to 0 to find the x-intercept. And I'll get 3x plus 4 times 0 is equal to 12. 4 times 0 cancels, it's just 0. So I get 3x is equal to 12. So x is equal to 4. This gives me the point 4, 0 as my x-intercept. So now when I come over to graph, all I need to do is plot my x and y-intercepts. So when I plot 0, 3, I get actually that same point that I got on my previous equation. And when I plot 4, 0, I get a point on the x-axis. So now, So now, if I come back and draw the line, it should look something like that. I'm a little bit off. Let me try again. Yeah, that's a little bit better. And since we graphed these two equations on the same coordinate plane, I just want to point out to you guys that this is technically graphing a system of equations. And we can see the solution to the system is that point of intersection. And even though my lines aren't drawn in perfectly, we can see that that was a point on both graphs. So the solution to the system is 0, 3. Alright, so now I'd like to look at some graphing of inequalities. So these are actually the same two equations, except I've now turned them into inequalities. So the only thing we need to do differently now is we have to think about whether we're going to have a solid or a dashed line. And that depends on the inequality symbol. So if it's an or equal to, if it has the line underneath, it looks like a less than or equal to or greater than or equal to, we're going to have a solid line. And if it's just a less than or greater than without the line underneath, that's where we're dashed. So if we look at the first example, if we look at example 3, I look at that symbol, I have a less than or equal to, so I'm going to draw a solid line when I go to graph. So just like I did when I first graphed this line on the previous slide, I'm going to go up to my y-intercept and plot it at 0, 3. Then we're going to go down 1 and over 2 to get a couple more points on my line. I will then connect those points to form a line. Now this is still just a line. It's not an inequality until I have to decide on the shading. So the key is I'm either going to shade below the line or above the line, and that represents all of the solutions that make the inequality true. So the key here is you have to plug in a point on one side of the line and see if it makes the inequality true. A great point to pick is always the origin, right? Because that's just the point 0, 0. So if we plug in 0, 0 into our inequality, what happens? We get 0 is less than or equal to negative 1/2 times 0 plus 3. So we get 0 is less than or equal to, well, negative 1/2 times 0 is 0 plus 3. Is that true? Is 0 less than or equal to 3? If the answer is yes, and it is, that's telling me I should shade on the same side as that point I plugged in. So I'm going to shade now below. All right, so now let's move on to the second example, or the fourth example overall. And this is the one where we had to find the x and y intercepts. So if we just flip back to the previous slide, you'll remember that the x-intercept was 4, 0, and the y-intercept was 0, 3. So plotting those same points, there's 0, 3, and there's 4, 0. Then I can connect. Now, in this situation, I don't want to just draw a solid line, because if you see, I don't have the line underneath my inequality symbol. So that means I need to do a dashed line. So I'm going to try to do this freehand. We'll see how it goes. The idea is you're still thinking about connecting the dots, but your line is not solid. Now we have to decide shading for this second inequality. So again, to do that, we can plug in the origin point 0, 0. So if I do that here, I get 3 times 0 plus 4 times 0 is greater than 12. So that means 0 is greater than 12. Well, is that true? No, it's not true. So what that tells me is I need to shade on the other side of my line. So let me change my color real fast. Alright, so what that means is I need to shade on the opposite side from 0, so that's up here. Now, since I graphed two lines on the same coordinate plane, this is technically a system of inequalities. So if you take a close look, there's this little sliver in here, I'm shading it in blue, where the yellow and the red were overlapping. That is the solution set to this system of inequalities. One more thing to go over with you guys. I want to talk briefly about graphing vertical and horizontal lines. So whenever you see, well, actually these are all inequalities, not lines, but same idea. So when we're graphing and we see x is less than 3 without any y's, or x is greater than negative 2 without any y's, that's telling us to graph a vertical line. And the way in which we do that is it says x is less than 3. So that means we first want to think about the line, where is the x value of 3? So x value of 3 is over here. So all the points that have an x value of 3 lie along this vertical line. And I drew it dashed because of the inequality symbol that I see. So now if I think about which side of my line I want to shade on, I can still think about plugging in 0 for x. And what would I get if I plugged in 0 for x? I'd get 0 is less than 3. Is that true? Yes, it is. So that's telling me to shade this way. We can also just think about common sense in that the left side of the number line are smaller numbers. So if we want x less than 3, we want to shade to the left. Looking at our next example, we have x is greater than or equal to negative 2. So if I find negative 2 on my graph over here, and now this time I am going to draw a solid line because I have the or equal to symbol. And then I need to think about shading, so I need x greater than or equal to negative 2. So that's telling me to shade to the right, because these are where the values are greater than negative 2 for x. Coming over to the horizontal side of things, my first equation is y is less than or equal to negative 1. So the idea is we find negative 1 on the y-axis. And because it's an or equal to inequality, I'm going to draw a solid line. Now to think about shading, where are the y values that are less than or equal to negative 1? Well, that's below this line. Last example, we have y is greater than 2. So if I come to my graph and I find y value of 2, that's over here. Oh, I accidentally drew a solid line, but actually I want to draw a dashed line because I don't have that or equal to part of my inequality symbol. And then for my shading, it's y is greater than 2. So that would be shading above because this is where the y values are greater than 2. Alright guys, that's the end of this video. I hope this helps you out. It should help you out for class on Monday.